Well, hello. Here we are at 10.3, solving triangle similarities. All right, in 10.2, we did similarities, but this time we will be proving triangles are similar. Okay, so just a quick review of what we did before, or I guess not really a review, but if two shapes are similar, that means that the corresponding angles are congruent and corresponding sides are proportional. All right, so we need to make sure we remember those and the wording that corresponds to similar triangles. All right, sounds good. If you want to know if two triangles are similar, then we will be looking to show these two things. So we'll want to find either corresponding angles or corresponding sides. Okay. Luckily, we don't have to show that every single angle is congruent and that every single side is proportional to show that two shapes are similar. If we can find some of the sides are proportional and that some of the angles are congruent, then we can infer that the rest of the sides and angles will follow the same pattern. All right, so I know that many of these you guys have done this before, and whether it be 7th grade, 8th grade, several people have commented that this is exactly the same of what you guys did before. So this may just be a review for some of you it may be brand new. All right, so there are three different ways to show similarity. One of them is angle-angle similarity theorem. Okay, we have two others. One is side angle side and side side side. And we'll learn about all three of those. So angle-angle similarity theorem states that if two corresponding angles are congruent, then the triangles are similar. All right, so let's look at these two triangles. Looking at them, obviously we have a pair of corresponding angles that are congruent. Okay, but we need to find that there is one more. So here we know that triangles are 180. We could subtract 59 minus 37, and that ends up giving us 84 degrees. And here we have another set of congruent angles. Okay. All right, so there are three types of problems that you may run into. One is where they give you the angles. So for example, A, they give us angle L, and they also tell us that angle D, those are the same angles. Same with angle E and angle K, that these are congruent angles. And so we just said that if we have two triangles that have the same two corresponding angles that are congruent, then we know that these are similar triangles. So here we would say that they are similar by angle-angle similarity theorem. All right, and they also want us to complete the similarity statement. So we look at this, we'd want to write them down. So for example, L, which has this angle with one angle thing, okay, that corresponds to D. So we'd write triangle D, and then we have K corresponds to E, and then J corresponds to F. All right, order matters. If you just throw those letters in there, you're going to lose points. Okay, so enough said. Sorry about my voice. I'm a little sick. I'm trying to get over a cold. So, all right, B. We have another example, and here we may have something that may help us is vertical angles. So whenever you have two lines that intersect each other, that gives us vertical angles. Okay, and vertical angles are congruent. Okay, so they're the same. All right, so we need to have, for angle, we have to have two sets of congruent angles. So right here we have one. We need to find another. All right. But realizing that this angle, both of these angles are the same, and we know that one of these angles is 73, and that doesn't match either of these other two ones, there's no way that we could have another set of congruent angles. And you could prove it to yourself by saying 180 minus 70 minus 76. That would give us 34. We would know that this is already 34. And then the missing angle that we have would be 180 minus 34 minus 73 gives us 73. So yes, maybe we have these two that are congruent, but we need to have, they need to be corresponding angles. So for example, this angle and this angle, those are not congruent. And this angle and this angle, those are not congruent. So we would say that these are not similar and would be done. Okay? All right, next one, C. This is the other thing, the three things that may help us. The last is parallel lines. So there's a relationship between parallel lines and angles. Whenever you have a line that crosses those parallel lines. These lines that cross two parallel lines are called transversals. Okay, they transverse the two parallel lines. And the relationship between two parallel lines and a transversal is that we have alternate interior angles. All right, so basically saying that those two angles are congruent. All right, so alternate interior angles. So that's something you'll want to remember. Okay, we have another transversal, coloring it red. These are also alternate interior angles that are congruent. So now we have two sets of congruent angles. We can say, yes, these are similar by angle, and we'd want to write down the similarity statement. So J corresponds to J, K corresponds to E, and L corresponds to F. And like again, they need to be in order. All right, let's go to our next one. Side, angle, side. Similarity theorem. Okay, if any angle in a triangle is congruent to an angle of another triangle, and if the included sides of these angles are proportional, then the two triangles are similar. So let's look at this a little more by just looking at this. All right, so it says that we need to have two congruent angles. So here we know that these are congruent. These are vertical angles. Okay, and then we also need to prove that the sides that are next to those angles, that those are proportional. All right, so for example, sometimes I like to choose the largest, so we'll do 12, and the largest for the small triangle is 6. So these are corresponding sides. All right, so we want to see if they're proportional. So 12 divided by 6, that gives us 2. And now we'll use the other corresponding sides, would be 10 divided by 5. And as you see, both of those sides are proportional. The scale factor is 2. So by that, we know that these are similar triangles by side, angle, side, SAS. All right, so let's do some examples. If you can, pause. and trying if you can do them by yourself. State if the triangles are similar or not. Then complete the similarity statement. All right, so let's look at these two triangles. One of the things, if we're doing side angle side, we need to make sure that the angles are congruent. So check, we're good with that. And then we also need to find that the corresponding sides are, are proportional, right? Proportional. All right. So for example, 36 divided by 9, is that equal to 37 divided by 9? And you'd say, of course not. I mean, they're similar, or they're close, but they are not exactly the same. So by there, we would say that these are not similar. Next one. Okay, we have vertical angles here, so we could say that angle BAC is congruent to angle UAV by vertical angles. Okay, and then we need to find that we have two sets of corresponding angles. Okay, so we need to make sure that they're proportional. So for example, I'd start with the highest, which is 30 for the big triangle, and the largest for the small triangle would be 10. So we could do 30 divided by 10. That gives us 0.3. And then we'd do the next set. We could do 27 and 9. 27 and 9. That also gives us 0.3. So we could say that they are proportional. The two sides are proportional. So the triangles are similar by side angle side. And we need to fill in the similarity statement. So A corresponds to A, B corresponds to V, and C corresponds to U. All right, last one. All right, we have a triangle inside of a triangle. They share the same angle. Therefore, we know that UTV, angle UTV, is congruent to angle QTR by the reflexive property. Okay, reflexive property is wherever we have the angles share the same angle. Okay, and okay, now we just need to also find that the two sides are proportional. Okay, so for example, the side of the small triangle is 54, and then the side of the whole triangle would be 54 plus 8. Okay, so that would be like, you could do the big triangle divided by the small triangle. So you could do 52 or 54 plus 8. That gives us 62 divided by 54. And that should be equal to the length of the big side of the triangle would be 77. 77 divided by 66. All right, and then you would plug those in your calculator. I'll do that really quick. So 64 divided by 54. That gives us a decimal, which is like 1.148. And is that equal to 77 divided by 66? Which is 1.167. So we would say no, they are not proportional, and we would say they are not similar. Okay? All right, last one is side, side, side similarity. So if all three pairs of corresponding sides are proportional, then the triangle is also similar. Okay? So you should use that whenever you have three sides for both triangles. For example, here's an example where we have three sides for both triangle, all filled in. okay, we would need to find those three proportions and make sure that they're all the same. So one way to do that is to choose the largest for both triangle. I'm going to do the large triangle divided by the smaller triangle, so 24 divided by 12. That should be equal to the next largest set, which would be 18 divided by 9, and then the next set, which is 14 divided by 7. And as you look at that, that's 2 equals 2 equals 2, so they are all proportional. So since they're all proportional, we can say that they are similar by side, side, side. Similarity. All right, so here's two problems. We want to see if they are similar triangles as well. So same thing, maybe we'd check the largest two. So we could do 55 divided by 42. That should be equal to the next largest, which would be 44 and 33. And then the next, maybe connect those, the smallest ones are 32 and 23. All right, and so just again, we always have for this case, we have the larger triangle on the top and the smaller triangle on the bottom. And it can be vice versa, but you just can't switch. Okay, so they just need to stay either on the top or on the bottom. All right, so you would want to plug that in your calculator. It ends up to be about 1.31, and then 44 divided by 33, which is like 1.33, and then we have 1.39. And as you see, none of these are proportional. So here would say not similar. Okay, and next one, same thing. They share the same, I guess it doesn't really matter. I mean, for this problem, since they share the same angle, you could solve this problem by using side angle side, or you could solve it by side, side, side. So since we're trying to do it with side, 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 let's just do side by side, side, side. Okay? Too many sides. All right, so for example, this would be our long triangle, our big triangle, which would be 70, and the corresponding side would also be on that same part, which would be 42. And that proportion should be the same for 50 and 30. And also, this long length, which is 55, divided by, now, wait a minute, this is the length of the triangle, which is right here. They give us 22, which is this part. Okay, so we would need to do 55 minus 22, and that would leave us with 33. All right, after that, you would plug those in your calculator, or you can simplify your fractions. Anyway, you do like 70 divided by 42. That would be 5/3, or you could write that as a fraction, 1.67. Okay. And then this one would also be 5/3, which would also be 1.67. And this one also would be 5/3, or 1.67. All right, so all of these corresponding sides are proportional. So we would say, yes, they are similar by side, side, side. And we need to write down the similarity statement. So K corresponds to K. L corresponds to C. And M corresponds to D. Sweet. All right, so here's some more practice. We don't know what type of proof that we're going to use, but just by looking at them, you have some good ideas. So here they give us 3 sides for both triangles, so you'd probably want to use it or prove it by side, side, side. Okay, so this is just kind of like what we did before. Largest and the largest. 72 divided by 27. That should be equal to the next largest would be 49 and 18. And then the next would be 40 and 16. So we plug these all in. 92 divided by 27. Okay. That would be 2.67. Okay, this one, 49 divided by 18. That gives us 2.72. And at that point, you don't even need to continue. I already found two that they're not proportional, and you would be done. But if you wanted to continue, you could. This ends up being 2.5. So none of them are proportional. So you'd say not similar. All right, here's another problem. What type of theorem are we going to use? Well, considering that these are vertical angles and we have two sides for both, would probably be wanting to use side angle side. All right, so we know that angle TDU is congruent to angle BDC by vertical angles. All right, and then we need to find the proportions. So here we'd maybe want to choose the largest side and the largest side. So 40 divided by 16, that should be equal to the next largest would be 25 and 10. All right, let's do 40 divided by 16. That gives us 2.5. And then 25 divided by 10 is also 2.5. So we know that they are proportional. So we know that angle DCB is similar to, we make sure we have them in the right order. D, what corresponds with C? It would be T. And what corresponds with B? It would be U. All right, so triangle DCB is similar to triangle DTU by side angle side. Okay, last one. We have two sets of sides, and you may want to realize that these are reflexive. Okay, so we have angle ECD is congruent to angle HCG by the reflexive property. Okay? All right, so we know that those two angles are congruent, and now we need to find the corresponding sides. So here, 40 would be our long side of the triangle, divide it by its smallest triangle, which is 30, and that should be equal to the length of the whole triangle, which would be 42 plus 14, which gives us 56, divided by the smaller triangle, which is 42. So we plug that in your calculator. 40 divided by 30. Oops. That gives us 4/3. 4/3, or in decimals it would be 1.33 forever. And then 56 divided by 42, that also gives us 4/3, or 1.33 forever. Okay, so we know that they are proportional, and because we have two proportional sides and one congruent angles, then we could say that angle CDE is similar to angle C. What corresponds to D would be G, and what corresponds to E would be H by side angle side. Okay, so you need to make sure you show your work. You don't just write down that that triangle is similar to that triangle by SAS. I'd like you to show your work how you know. All right, 2-column proofs. So on the test there will be 2 or 3 column proofs that you will want to be able to do. It's basically the same thing we've been doing, except it's a little more formal, and you need to state what you know and how do you know it. So statement is what you know and how you know it. All right, so let's look at these. We have these 2 triangles, and we want to prove that they are similar. So we've done a problem that is very similar to this. All right, one of the things, we have 2 sides for both triangles, and we could know that these 2 triangles are congruent by vertical angles. All right, so one of the things you may want to write down is angle QKP is congruent to LKM, and then how do we know? By vertical angles. All right, that's our proof. All right, next we also need to prove that the 2 sides are proportional to each other. All right, so how we would maybe do that is we would choose our largest side and our largest side, and this is going to be our reason. So we can do 156 divided by 65, and that is equal to, clear that out, 156 divided by 65, that gives us 12/5. If you simplify, 12/5. Okay, and then we'd also want to find the other corresponding side, so 84 and 35. 84 divided by 35. 84 divided by 35, which is also 12/5. And if you wrote it as a decimal, that would be fine. I think it's like 2.4. Okay, yeah, 2.4. All right, so we know that they are, that is our reason, and we'd want to write down our statement. So we need to know that we have 2 corresponding sides. So one corresponding side would be, we could do KL, okay, and that is also proportional to Q or KQ. All right, that they are proportional. All right, and then the same with the other set. We could say KM is proportional to KP. All right, now that we have 2 corresponding sides and angle between the 2 that are congruent, we can say that angle KML is similar to angle KPQ. And like again, these need to be the corresponding sides. So KM corresponds to KP, and ML corresponds to PQ, and so forth. All right, so make sure you have those in order. Okay, so all right, so see if you can do 6 by yourself. Think about it for a little bit, and you can pause if you need, and we'll go and finish the rest. Okay. All right. All right, so I was just looking at something really quick, seeing another example. All right. Proportional. I'm just trying to see what a proportional is. Okay, so next one. Sometimes they give us information. So, for example, TU is parallel to KJ, and that is given. All right, and we'll need to use that to solve these. All right, they don't give us any sides, so most likely we're going to be doing side-side. So we're going to need to find those sides. First off, we find one really easy, though those are reflexive angles, so they share the same angle. So for example, angle TLU is congruent to angle KLJ. So this whole triangle, okay? And you can say that those are congruent by the reflexive property. Okay, and then we need to find one more congruent angle. Okay, and it has to do with these parallel lines. Okay, so for example, UT and JK, those are parallel lines. And then we've talked about this a little bit before. This line crosses both of those parallel lines. Those are called transversals. We talked about that a little bit, or at least I talked about that a little bit. Okay, and whenever you have transversals that cross two parallel lines, we know that these angles are congruent. All right, and we didn't talk about exactly this specific situation, but we would know that angle LUT is congruent to angle LJK. And the reason you know is by corresponding angles. Corresponding angles. All right, so we have two sets of congruent angles, so we're done. If we wanted to, if you didn't want to use reflective property, you could find that these ones are also congruent by using corresponding angles as well. Okay, so here you just write down, you'd say, well, triangle LJK is similar to triangle LUT by angle similarity. All right, so here are some examples of types of angles whenever we have parallel lines. So this really only applies when we have parallel lines and we have those transversals that cross through those parallel lines. So for example here, I kind of put stars next to the ones that you'll probably need to use. So angle A and 1 and 5, those are corresponding angles. Okay, and we could find some other corresponding angles, for example, 2 and 5, or 3 and 7, or 4 and 8. Okay, sometimes we have these types of problems when we have a triangle inside of a triangle, and we have these corresponding angles that are congruent. All right. Another types of problems are like these. This was one of the earlier problems where we needed to use angle. Okay, so here we have two parallel lines and we have a transversal. All right, we know that these angles are congruent by alternate interior angles. So for example, 4 and 6 or 3 and 5, right? And I give you a little example of that as well. Okay, we have consecutive interior angles and alternate exterior angles, those won't really be using, I don't think, for this unit, but we will be using vertical angles, and we've talked about that a couple times in this unit and last unit. All right, so if you have any questions, please let me know. I'm just going to go over the homework really quick. So there are 16 problems. Make sure you write or read the instructions. So state that the triangles in each pair are similar. Okay, sometimes they're not. If they are, you need to state how you know. So whether you're using angle angle or side angle side or side side side, you need to say how you know that they are similar. Okay, and you need to show work. Don't just look at them and say, those look like they're similar, and I'm going to write down the similarity statement. That won't give you points, okay? I mean, at least it maybe give you some points, but when you do your similarity statements, make sure you write them down in order, okay? So, for example, write them in order. So, for example, they give us an angle. Those are congruent angles, okay? And they give you two sides. So, which side corresponds to which side? So, I always like to choose the small or largest and correspond it to the largest for the other triangle. And then you could do the same for this one. The smallest corresponds to the smallest. All right? So make sure you show your work. The first 12, you don't need to do a formal 2-column proof, but the last page, you will need to be writing down 2-column proofs. So you need to have your statement, okay, what you know and how do you know it, which is your reason. Okay, so for example, you could say something about these are vertical angles. So you could say angle CAB is congruent to angle SAT. Okay, the reason is vertical angles. All right, so like I said, on the test, there's going to be a few of those problems, and they're worth quite a bit. So make sure you feel comfortable being able to write down a 2-column proof. All right, thanks for your time, and let me know if you have any questions.